The Jacinto 7 processors provide a unique set of application-specific hardware accelerators. Although highly configurable in software, these hardware-based accelerators provide much higher effective performance for key system functions versus implementing those same functions on soft processors. They also provide the benefit of offloading tasks from the main processors and achieving higher system performance in a lower power and thermal budget, thus also reducing system costs. In this section, I will give a brief overview of the key hardware accelerators, including capture, vision, and imaging accelerators, deep learning accelerators, and display and video accelerators. Other relevant accelerators supported in the architecture include audio and radio, security, and Ethernet switching. TI has leveraged over 10 years of experience in advanced driver assistance systems, or ADAS, and image signal processing to create a highly optimized hardware image processing chain to accelerate vision and imaging, which can be used to also improve convolutional neural network or CNN-based deep learning algorithms. The chain begins with two MIPI standard CSI2 interfaces, each supporting up to 4 data lanes with multi-stream support using CSI virtual channels. There are two major processing blocks: the Vision Processing Accelerator, or VPAC, and the Depth and Motion Accelerator, or DMPAC. The VPAC module implements a vision-tuned image signal processor, which implements an industry-first, fully flexible raw pattern processor to tune the signal stream specifically for vision processing, and can eliminate the need for expensive custom FPGAs or external ISP chips. Lens distortion correction, edge filtering, and region of interest, or ROI layer creation, all work to reduce DSP loading, reduce power, and increase overall system performance in a vision system. The DMPAC module implements high-performance, best-in-class algorithms, including high-resolution stereo disparity and unique dense optical flow algorithms, tracking many points versus sparse flow, which is used in traditional systems. These features can highly augment CNN and deep learning system performance, and also augment multimode systems, including other sensor types such as LiDAR or radar. Overall, these imaging features increase the quality of the ADAS systems and provide options for reducing system costs and power by eliminating external chips and offloading tasks to increase available DSP MIPS. As mentioned in the previous C71X DSP section, another very key hardware accelerator is the Matrix Multiply Accelerator, or MMA. The MMA is architected to optimize data flow management for deep learning, while minimizing power and external memory devices. The MMA is accessed as an extension of the C71X instruction set and leverages the same highly parallel data path as the C71X. This streaming engine is a 6-dimensional data movement engine which is able to keep the MMA constantly fed with data from the L2 memory. The Multi-Core Shared Memory Controller, or MESMIC, has a local DMA which can page data from the L3 memory to the L2 memory and from the DDR memory to the L3 memory. This slice-based processing approach allows for full efficient utilization of the MMA while minimizing external DDR bandwidth and the number of external DDR devices required. The result is a much higher effective performance per TOP, or tera operation per second, in actually performing deep learning tasks, as seen by this benchmark comparison where the Jacinto 7 processor is achieving higher frame rates while using less TOPS and less memory bandwidth. The TI Deep Learning, or TIDL, software framework realizes this data flow management technique so that this performance is readily accessible to the software user. Overall, the TI Deep Learning solution is optimized for real-world performance in modern networks such as MobileNet, ResNet, and ShuffleNet, and not based solely on less meaningful TOPS ratings. It is optimized for automotive as it is architected from the bottom up for functional safety, and it targets reasonable DDR system costs, power, and thermal budgets necessary to operate within the automotive environment. The Jacinto 7 display subsystem provides multiple display output options, including MIPI-compliant DSI or Display Serial Interface output, embedded DisplayPort output, and legacy parallel outputs. The subsystem supports 4 hardware pipes or layers with 4 independent output overlay managers, which can blend the pipe data in various ways. Standard resolutions such as 1080p, 2.5K, or 4K can be supported, but also the frame and line sizes are highly flexible to support non-standard panel resolutions. This includes options to even merge pipes and support very wide resolutions up to 6K or 8K, depending on available system bandwidth. Frame buffer decompression and load balancing is available to minimize DDR bandwidth. The decompression algorithm works in conjunction with the compression implemented in the GPU. The display subsystem has multiple safety and security features which are tailored for automotive, including freeze frame detection and pipe and resource isolation. Different pipes may be owned by different software tasks of varying safety and security levels, even if they are blended to the same output. These features are highly valuable for secure content playback and for protecting dedicated safety layers in a system which also has non-secure or non-safe content. The DSS can also directly leverage the real-time IO-MMU resources to achieve on-the-fly defragmentation of buffers which are scattered in the memory space while still meeting real-time requirements to drive the display. This is highly useful for virtualized systems. Jacinto 7 implements PowerVR video decode and encode solutions from Imagination Technologies. The decoder supports multiple standard formats and can concurrently decode up to one 4K stream at 60 frames per second or up to 8 1080p streams at 30 frames per second, or combinations in between. The encoder supports multiple standard formats and can encode up to one 1080p 60 stream or two 1080p 30 streams.
Thank you for watching this training. For more information, refer to the links shown. For questions about this training, go to the processor forums at ede.ti.com.